Alright, my fellow compiler wizards, today we're going to take a look at the first programming assignment for the compiler course. So let's get into it. This programming assignment requires you to implement a lexer, also called a scanner or a tokenizer, for the Ada programming language. As discussed in Lecture 2, a lexer provides a stream of tokens, also called symbols or lexemes, given a stream of characters. So let's look at the Ada language specification. Ada. In this course, you'll start by building a compiler for a language called Ada, named after the Greek letter Eta. Ada is an imperative procedural language like C. The next generation of the language will have additional features to help build more complex programs, but at present, developers must make do without them. This document gives a brief specification for the Ada language. Toward brevity, the specification is deliberately vague about some issues. Part of your task is to resolve any ambiguities in the specification in a reasonable way. Identifying and resolving specification ambiguities is an important job for any engineer. You may also make extensions to the language as long as they are backward compatible. Syntax of literal integer constants now allows 0. Multiple assignment feature was extended in expressive power. Okay, Ada programs consist of a single source file containing definitions of one or more functions. Execution of a program consists of evaluating a call to the distinguished function named main. The language has two primitive types, integers int and booleans bool. The array type T exists for any type T, so T represents an array of arrays, so you can have two-dimensional arrays. I just had a thought, so we're definitely going to need to throw an error if there's no main function detected. Just pin that thought for later. Functions may return a value, but they don't need to. In Ada, a function that does not return a value is called a procedure. A function may take multiple arguments. Unlike in languages such as C and Java, a function may also return multiple results. Statement and expression forms should largely be familiar to C programmers. There is no string type, but the type int array may be used for most of the same purposes. Literal string type constants have this type. Alright, so obviously you convert integers, or you convert your string to an array of ASCII codes. Variables are declared by following them with a type declaration and an optional initialization expression. There are no holes in scope. A variable may not be declared when another variable of the same name is already in scope. Here are some examples of variable declarations in Ada. X is an integer, it's equal to 2. Z, notice the semicolons are optional. Z is an integer, undeclared, undefined. Boolean, you can declare multiple on the same line by the looks of it. You can set an integer equal to f of x. Oh, no, it's evaluating. Yeah, so you can evaluate a function on the same line as you declare a variable. String integer array equals hello. And yeah, I'm guessing it converts it to ASCII code. A variable declaration need not initialize the variable, as the declaration of Z shows. Use of the value of an uninitialized variable has undefined behavior. Ada compilers are not required to detect the use of uninitialized variables. This would be a nice extension to the language. Identifiers, including variable names, start with any letter and may continue with any sequence of letters, numbers, the underscore character, or single quote characters. As in Java, variables are in scope from the point of declaration until the end of their block. A variable declaration may occur in the middle of the block, as in Java. A variable declaration that is the last statement in its block is in scope nowhere. A variable declaration that is the last statement in its block is in scope nowhere. Wait. Variables are in scope from point declaration. Yep. The value of a variable can be changed imperatively using an assignment statement, as in the following examples. Cool. Function definitions. Program contains a sequence of function definitions, including the definitions for the function main. All functions in the program are in scope in the bodies of all functions. Wait. All functions in the program are in scope in the bodies of all functions, even if the use precedes the definition. Okay. Hence, functions may be recursive or mutually recursive. Function definition starts with the name of the function, followed by its arguments, its return types, and definition of its code. Only one function with a given name can exist in the program. There's no overloading. For example, below is a function to compute the GCD of the greatest common divisor of two integers. The body of the function is a block of statements. The result of a function is returned using the return statement. To simplify parsing, any return statement can only occur as the last statement in its block. Return the greatest common divisor of two integers. While a is not equal to 0, if a is less than b equals b minus a, else a equals a minus b. Cool. Multiple results. Unlike C or Java, a function can return multiple results, indicated in the function definition by giving a list of return types. So here we can return multiple integers. Cool. Never seen that before. If this list is absent, the function is a procedure. The result of a function is a list of expressions separated by commas. For example, the following function returns a pair of integers. Awesome. Results from a function that returns multiple values can be used only through multiple assignment, in which the left-hand side is a sequence of other assignable expressions or variable declarations. For example, line 2 in the following code is the effect of assigning 11 to P and 15 to Q. Q equals... Wait, what? Of assigning 11 to P. P int. Q... Right. Okay. Yeah, right. So this function returns two integers. The first one gets assigned to P. The second one gets assigned to Q. The pseudo variable underscore can be used to discard one of the results. Yep, seen this before in Brown University's CS19 course. We use this in their programming language called Pirate. That's cool. A multiple assignment can also be used with a right-hand side that is a comma-separated list of expressions. So I suppose we shouldn't really be thinking about how to actually implement this entire thing as a compiler. We should just be focusing on how we're going to tokenize this stuff. Yeah, cool. So we can come back and reference this document. It's probably a waste of time to read the entire thing right this second. Here we go. This is interesting. Precedence. That'll be handy when it comes to syntactic analysis. Here we go. Lexical considerations. The language is case sensitive. An input file is a sequence of Unicode characters encoded using UTF-8. Therefore, ASCII input is always valid. Comments are indicated by // followed by any sequence of characters until a new line character. Keywords use if while else return length may not be used as identifiers, nor by the names of values of the primitive types int, bool, true, false. String and character literals should support some reasonable set of character escapes, including at least double backslash, backslash n, new line character, and backslash apostrophe, I'm guessing. In addition, an escape of the form -x, where HHHHH stands for 1 to 6 hexadecimal digits. Okay. Upper or lowercase represents the Unicode character with the corresponding code. For example, -x 0a is the same as -n. Okay. You may be more successful parsing negative integer literals as the negation of a positive literal. Okay. The EDA compiler compiles a source file with extension .ada to runnable code. It may also read in interface files that describe external code to be used by the program. Interface files contain a non-empty set of procedure and function declarations. Prints a string to standard output. That's not important right now. Cool. Alright. The actual assignment. Solution will be graded on design correctness and style. Good design makes implementation easy to understand. Yeah, a few suggestions. You should use brief but mnemonic variable names. Yep. Basic stuff. Partners. You'll work in a group of 3 to 4 students. Not us. We are doing this solo. Find your partners as soon as possible. Set your group up on CMS. Blah, 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 blah. Please ensure that all Java code you submit is contained within a package. Not important to us. This assignment is much smaller than future assignments. It is intended primarily as a warm-up that gives your group the chance to practice working together. Later assignments will stress your ability to work effectively as a group. Blah, blah, blah. Blah, blah, blah. Group stuff. Design overview document. Here we go. We expect your group to submit an overview document. The overview document spec outlines our expectations. Writing a clear document with good use of language is important. I actually personally should probably do this because I have been writing some documentation at work and I have like very little experience with it. So I'm just going to have a quick squiz of this for my personal interest. Summarize your note with the aspects of the rest of your work for the overview. Which parts of the assignment were the most challenging? Interesting design decisions that you made, major issues that ran into, known problems with the implementation. Yeah, this is awesome. I definitely want to do this just to practice this. And when I come back to this, to look at my code on GitHub, like in a year's time or something, this is going to help a lot. Yep. I am going to definitely give this a crack. All right. Yeah, some key topics to include. Have you thought about the key data structures in this assignment? Have you thought about the key algorithms identified implementation challenges? Have you thought about your implementation strategy? Do you have a testing strategy that covers the possible inputs? This is actually something that I've been thinking about, and I want to do something called property-based testing, which is where you generate a bunch of like sequentially generated data or even randomly generated data, and you don't actually do concrete tests. You test the properties of the output. So you test that the input has the right relationships to the output. I don't know. You could test, like, you could expect an example of a property is like you expect the input string to be the same length as the output string or something like that. You don't actually test specific values. So I definitely want to figure out some way of testing this, because test-driven development and property-based testing is something that I want to use more at my own job. So I'm going to give that a shot. Version control, don't need to worry about that. Lexa. We encourage you to use a Lexa generator such as JFlex in your implementation, but it is not required. If you do use a Lexa generator, you may wish to consider the adapter pattern to aid you in your implementation. An example grammar file for JFlex is included in the release folder that you might find useful to peruse. What is the adapter pattern? It's a software design pattern, also known as a wrapper, an alternative naming shared with the decorator pattern that allows an interface of an existing class to be used as another interface. It is often used to make existing classes work with others without modifying the source code. Okay, yeah, so a wrapper. An example is an adapter that converts the interface of a document object model of an XML document into a tree structure that can be displayed. Cool. Converts one interface to another so that it matches what the client is expecting. Adapter. Okay, so if you use the Lexa generator, you may wish to consider using the adapter pattern to aid you in your implementation. So if we use Flex to generate C code, I'm assuming this means that we should be wrapping the output of that in our own wrapper so that we can essentially provide our own interface that we want to use then for but then at that point we would have, if we use a Lexa generator, doesn't that just solve our problem? I don't know, we'll keep reading. Command line interface is the primary channel for users to interact with your compiler. General form for the command line interface as follows. For this assignment, at least the following three options must be supported. --help, print a synopsis of options. A synopsis of options lists all possible options along with brief descriptions. No source files are required if this option is specified. Invoking etac without any source files should also print a synopsis. To see an example of a synopsis, run Java C from the command line. While that's downloading, we'll keep going. --lex, generate output from lexical analysis. For each source file named filename.eda, a diagnostic output file named filename.lext is generated to provide the result of lexing the source file. Each line in the output file corresponds to each token in the source file in the following format: line, column, token type. So, okay. A line and column indicate the beginning position of the token, and token type is one of the following: ID, name for an identifier, integer value for an integer constant, character value for character constant, Symbol for a symbol such as parentheses, punctuation, keyword. Okay. Non-printable and special characters in character and string literal constants should be escaped in the output, as well as Unicode character escapes as described in the EDA language specification. Unicode, yep, so we did see that. But ordinary printable ASCII characters should not be. Comments and whitespace should not appear in the output. A lexical error should result in the following line in the output file. Okay. Where description details the error. All valid tokens prior to the location of the error should be reported as above. All valid tokens prior to the location of the error should be reported as above. Table 1 shows a few examples of expected results. Content of input file, use input output, main args, 70 errors. No, it's just got like ID, keyword, what was the type of that? Symbol. Symbol is an operator. ID, integer, character. I didn't know there was characters. Character constant web value. I didn't see characters in the thing. Oh, in the language spec. That's alright. Doesn't matter. And dash D path. Specify where to place the generated diagnostic files. If given, the compiler should place generated diagnostic files from the lex option in the directory relative to this path. The default is the current directory in which etac is run. For example, if this path is P and the file is generated is a/r/se.lex, the compiler should place this file at that.lex. To pass command line arguments, it is common to use a library instead of implementing such functionality manually. That's perfectly fine and not difficult to implement it manually. Pretty sure C++ allows you to do that. I know C allows you to do that, so we'll look that up for sure. Below are the common libraries for various languages you might find useful. OCaml, command module in Jane Street core. See the real world OCaml adapter. Cool. Man, Jane Street are cool as hell, dude. So, if you don't know, I think Jane Street's this trading company, high frequency trading company, but they're like the biggest users of this language, OCaml. I think they make up, I don't know, like 80% of its real world use or something. And they maintain the what's it called? It's like a standard library for OCaml. And it's like just super cool how they're able to essentially adopt this obscure programming language for themselves and just turn it into this beast of a language that you can get extreme performance out of. Yeah, anyway, side tangent. Okay, the test harness is a framework for testing your implementation and for grading your submissions. Named ETH, the test harness has been tested to work in a 64-bit Linux virtual machine environment. The VM distribution contains instructions for setting up the VM on your machine. If this link is down, the VM has not yet been released. It's coming soon. The VM setup script will download and install the test harness along with other necessary components. Blah, 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 blah. ETH is installed in the F directory and can be invoked from the command line in a general form. Two options of particular interest. So I'm not 100% sure I want to bother with doing their test scripts because I want to be, I do want to be building my own specifically doing property-based testing on this, but that may be an issue because to do that I will need something that generates ETH ADA code. So we'll see. I may come back to this. You should submit these items on CMS overview. You don't really have to worry about this if you don't want to, but I am going to do that overview for sure. Small library, blah, blah, blah. Yep. So we're not using Java, so we're not going to worry about that Java specific stuff. Okay, here's an example of an error. So equals for all. That, I'm guessing that can't be. Where is the error? I would assume that to be an error for all, but I guess not. So IDX equals error invalid character constant. So I guess you have to escape those. This equals doesn't matter. Cool. All right. So okay, so we're not just. It's not just Alexa generator that we're. Sorry, it's not just Alexa that we're creating. We also need to create a program that shows that handles command line options and displays a little like synopsis of what it does. Yeah. I'm just wondering, is using Alexa generator just completely like taking away like 90% of the effort of this assignment? I mean, we still have to specify the regular expressions and stuff. So, oh well, I'll give it a shot. I'll still do it anyway. All right, cool. Gonna take a break and then I'll get into it in the next section. Okay, so from what I can see, we're gonna have to implement three main things for this assignment. First thing is the command line interface. That's going to need to include the following commands, or sorry, the following option types. The first one is help. And then Lex, which is what actually does the Lex, like actually tells it to do the Lexing and then outputs a file. And the third one was dash D. Yep. Simply dash D. And that lets you, that has to be used in conjunction with Lex. And that just tells you where to output the Lex files. So, yeah, it's going to look like this. Yeah, ATAC. So we're going to call the ATAC function, ATAC program. Then we're going to have our options list here, and then we'll have the source files. So an example would be .atac dash lex, and then some ATA file, One thing that we're going to have to think about with this is we have to include the dash lex with a dash d. So if we were to receive input like this, dash d, and then some directory, this is invalid because we haven't specified the lex. So we need to include lex if we include D. Secondly, we're going to need to figure out how to handle this help option. So if we just call .etac with no arguments, we're going to show the help. Then if we do it with obviously the dash dash help, also show the help. What else do we need to think about here? If we include if lex is included after the help, so or in the same options list as help, then I think we can safely just override the help and just do the lex. If we don't specify lex when we do the D operation, we can just throw an error. There may be more to this. For now, that seems okay. The second component we're going to need to think about is the actual lexer itself. So I'm going to attempt to build this with flex. Use flex. And then we're going to have to, like they were saying, build a wrapper around that so that we can plug it into our main program, which will also contain the CLI. Then the final thing we need to think about is testing. So they have their own testing harness, I think they called it, a testing harness. However, I kind of want to build my own just to learn more about it, just to get exposure to more test-driven development. You know what? I may actually download some or figure out how to install some C++ testing framework. Testing framework. I'll think about that more. I will look into that in a sec. So in terms of the places to start, I guess the command line interface would be a good place to start. It does depend. It's obviously going to depend on the lexer, but we can still make a start on this and just not actually do any lexing until we're ready. The next step, I guess, would be to figure out a couple things. I need to figure out how do you capture command line arguments in a C++ program. I'm sure that's not hard. I know you can do that in C really easily. Probably carries over into C++. And also need to figure out how to handle I guess how to parse these, because these will need to be parsed in a more basic sense. Like you don't want something like this to occur. You don't want -D, then followed by lex, then followed by your directory. Ideally, you want this and this to be next to each other. It's probably just a matter of throwing an error if there's not a valid directory immediately after the D. Wherever you see the D, even if it's after the lex, Probably not that difficult now that I think about it. So, cool. I suppose I'll get started on that. But first, I'm going to look up two things. I'm going to look up, I'll just do it. C++ testing framework. Right, unit tests, Visual Studio, unit testing frameworks from 2016. Google test? Okay, seems reasonable, I guess. And the second thing is C++, how to handle CLI args. 3 ways to pass. Medium, no thank you. Here we go. When was this? This is using Boost. When was this? Oh, this is like 14 years ago. It can't be that difficult. Yeah, here we go. To pass command line arguments, we typically define the main with 2 arguments. The first argument is the number of command line arguments, and the second is a list of command line arguments. So, let's see, C++. You have entered argc arguments. argc and argv. You've entered 4 arguments. So the first one is the main function, the program name. Cool. Platform dependent formats are also allowed by the C and C++ standards. For example, Unix, they're not environment, otherwise accessible through getenv. They pass the main function. Their parameters arguments supplied to the program when it is invoked. They use to control programs from outside instead of hard-coding those values. argv argc is a null pointer. argv0 holds the name of the program. argv1 points to the first command line argument. Note, you pass all the command line arguments separated by a space, but if the argument itself has a space, then you can pass such arguments by putting them inside double quotes. Okay. Program name is a.out. No extra command line arguments passed other than the program name. If argc equals 1. Alright. Alright. Okay. It's not too bad. So now I need to think about this testing framework. How do I want to do this? Let's read the docs, see what the docs say. Google Test helps you write better C++ tests. Blah, blah, blah. Supports any kind of test, not just unit tests, okay? Test should be independent and repeatable. Test should be well organized, reflect the structure of the tested code. When tests fail, they should provide as much information about the problem as possible. Testing framework should liberate test writers from housekeeping chores. Assertions. Google text assertions are macros that resemble function calls. You test a class or a function by making assertions about its behavior. When an assertion fails, Google test prints the assertion source file. Line number location along with a failure message. We also supply a custom failure message which will be appended to Google test message. Cool. The assertions come in pairs that test the same thing but have different effects on the current function. Assert versions generate fatal failures when they fail and abort the current function. Expect versions generate non-fatal failures which don't abort the current function. Yep. Expect a preferred. However, you should use assert if it doesn't make sense to continue. Since a failed assert returns from the current function immediately, possibly skipping cleanup code that comes after it may cause a space leak. Depending on the nature of the leak. Blah, blah. So expect we iterate over x, expect xi to equal yi. If not, vectors differ at index I. That's pretty cool. I like it. I like it. Simple tests. Test suite name, test name. Test factorial test handles 0 input. Test factorial. So the names, are they not so the test suites, are they defined elsewhere, or is this just how you write the names? When naming your test suites and tests, you should follow the same conventions naming functions and classes. Oh yeah, test fixtures, right, that's cool. Yeah, I know we had an issue at work where we basically had, we weren't using a text fixture on a test that counted the difference between minutes, and it caused a test to fail when the minute ticked over literally between the different function calls within the test. So it caused an error, and debugging that was going to be difficult. Luckily, my coworker had an idea of what had happened immediately, and yeah, we ended up fixing it. So fixtures. So what we should have done is, and what we ended up doing was basically applying a fixture to the time. We're using time dot like the current time. So what we needed to do was to record the current time when the test began, and then not access the current time from the system again later. We should record the current time at the start of the test and use that recorded value for the rest of the test. Anyway, getting off topic. So, all right, cool. Is there like an installation thing? Invoking the test and test F implicitly register the test as Google test. Writing the main function. Fixture for testing class foo. int main return run all tests. Do they have an installation? All right, anyway, we'll start building the project and see if we can get this set up. Oh, do I not have VS Code installed yet? It's just called VS Code. You know what? I'm just going to use my software. Code. I'm just going to pause this until I get set up completely with my environment. Alright, so now I'm all set up. I've got my environment set up. I've got CMake installed, and I've got the Google Test Suite installed, and you can see here we've got tests running now. So the next step is going to be handling these command line arguments. Something I just discovered, and I'm embarrassed that I haven't discovered it earlier. I was considering making a Jira board for this assignment that I'm working on, but it turns out that GitHub has its own version of that, which is really cool. You can make tickets and assign yourself to them and organize things into these columns where you have to do, in progress, and done. You click on a ticket, it allows you to write markdown. So here's a ticket that I'm currently working on. Yeah, I just find this a really good way to organize myself and organize my thoughts. You offload everything to the to-do column, and then if you have a terrible memory like me, then this is a super useful tool to help you. Yeah, just want to put that out there. Okay, so I've pretty much finished part 1 now. So basically, what I have at the moment is a program that takes in command line arguments. It hits a function called handle command line arguments. Those are processed. Essentially, it does a very simple parsing of the command line arguments, and then the command line arguments will contain a list of file names. So it will send each file name to a lexing job, which will then do the actual lexing, which I have not implemented yet. But yeah, basically this function here, handle command line arguments. If you run the program without any arguments at all, it'll print the synopsis as per the assignment specs. And if you actually give it proper, if you give it malformed input, it will throw exceptions, and it returns a custom data type that I built myself. Where is it? Lexinfo, which just contains an output file name, an output directory name, and the input file names of the file that's going to be lexed. So this gets passed to the lexing function, which is basically step 2, the next step. So I implemented the Google test library. I had to override the Google test library because it accepts the command line arguments as well. So if you type, if you do, for example, if I run my program and then type --help, that would override any help function that would override my function essentially, and it would print off the Google test help function, which is not what I wanted. So I had to override that to get it to actually print my one. So what should happen is when I enter this, it should say printing synopsis, which is a placeholder for the synopsis, which I'll add later. And that now works. So we're not getting the Google test help info anymore. Another thing that I've added is the Google test. The tests themselves, they basically test a bunch of different malformed outputs. My mouse is currently dying. So if we go look at the tests, here we're testing that if we supply it the following command line arguments, ETAC, the name of the program, --lex flag followed by some file names, we expect it to return. We expect this handle CLI args function to return a lexinfo, the custom data type containing no output directory name and an input file name. We actually expect a vector full of those. So that's basically the test here. We can also test that. We also make sure that if we give it a missing lex flag, then it's going to throw. So example, if I give it -d and then .hello, this should throw because we haven't specified any input file names for it to start lexing. So what happens. Yep. And it throws. So aborted, the core is dumped. So I've probably got do I have memory leaks? Probably have memory leaks. I am going to check that with the address sanitizer after this, definitely. So yeah, that's pretty much where I'm at now. Implemented these tests. Oh, forgot to show you running the actual tests. To run the actual test, I run my program and then give it the -- test flag. And if you look in the main function, we have a function that basically looks at all the command line arguments and says if there is a -- test flag in there, just then run all the tests. Otherwise, actually process the command line arguments properly. So we should see a bunch of tests run now. Looks all good. All tests run and they all pass. Cool. So now I'm going to move on to actually figuring out how to use this flex program. Definitely going to have to spend some time looking at this. So here we go. Quick update on the Flex Lexa that I'm building. Things are going really well. So I've actually managed to get Flex working, and I've generated a Lexa program, which is super cool. If you have a look, it generates this file, lex.yy.c. Yeah, it's just this massive C file that's quite obviously auto-generated stuff, but yeah, it literally parses almost exactly what I want it to, which is cool. I still have a little bit more to go on working out a few kinks, so I'll give you a little demo. So if I build this Lexa, and then we run the Lexa itself. Actually, let's clear, then we run the Lexa. So what I'm going to do now is paste in some text from the assignment spec, and I'm going to see how well it matches up what my Lexa is doing to what they want the Lexa to do. So I'm going to paste that in now, and immediately, so this is the text I pasted in, immediately it starts lexing. So here you can see at line 1, character 1, we get this keyword use. Then at line 1, character 5, it detects this ID IO. And then at line 3, we detect this ID main, then we detect the parentheses, and so on and so forth. So let's compare with the actual assignment, what they want us to have. It's very close. So you can see we have 1-to-1 use, 1 and 5 ID IO. You can go through and check. It's pretty close. The one thing that I'm not finished is this this thing here, which is like I think it's some kind of Unicode escape character thing. So I'm going to need to figure out how to detect these escape characters within a string literal itself. So I'm probably going to have some sort of separate rule that happens here. So with the input file, pretty much what you're seeing here is a bunch of, so this file gets fed into the Flex program, which generates the Lexa program for me. So yeah, it's pretty simple. You have some variables over here, and these variables represent regular expressions, and then when we detect regular expressions, what we can do is define a rule. So over here, when we detect a comment, for example, we perform an action. In this case, the action is nothing. We just ignore the comment. When we detect when we detect a character, we simply print to standard output exactly how the assignment wants us to print it out, and then we increment the column numbers to keep track of the column numbers and the row numbers. Yeah, so it's pretty straightforward stuff. I had a lot of I spent a lot of time like working out little kinks, like you've got to escape certain characters so that Flex doesn't yell at you. But yeah, we ended up getting there in the end. Very close to finishing this. So right now I'm going to look into defining an extra rule set where I can potentially some sort of shift into a different phase. So all of these rules are defined in a single phase. I'm going to have to add some second phase that we go into when we're inside a string literal and we're looking for these Unicode escape characters. So yeah, onwards and upwards.